So a bit of an advanced notice, if you have a QR reader ready, start the app, there will be a QR code for a predecessor talk that you might not want to scribble down, but just snapshot. So get that app up and running if you want. Okay, so let's get started. My clock says 2 o'clock. Welcome to the talk about string views, the usual talk that I hold at Qt World Summit, updated now for 5.14, Qt 5.14. My name is Marc Mutz. I'm a senior software engineer at KDAB. That's short for Klabberdaberdalens Dataconsult AB. It's not, but nobody can pronounce the real name, so that's not a problem, except the founder, maybe. So we call us KDAB. So without further ado, string view, past, present, and future. Past. So I have been here 2 years ago and had just more or less the same talk, but on about different subtopics. So back then it was called string view everywhere. And I told the precise difference between a QString and a QStringView, why you would use QStringView over QString, how you would use QStringView idiomatically. I presented that QStringView is mostly useful as an interface type in the API, because it's non-owning. You would not store something in there over a function call. I presented some API patterns for QStringView. In particular, I showed how you can overload QStringView taking functions with QString taking functions, which is important for us because we have a lot of QString functions and we want to gradually add QStringView overloads, and they should not be ambiguous. So for anything that you can pass to that overload set, it will pick exactly one of them and it will never be ambiguous currently. I have heard last talk just now, and we will see how much of that survives Qt 6. I also showed some advanced pattern of how to use QStringView as a key element into a QHash or a stud map, and to get heterogeneous key lookup, which we're missing even from C++17 in the standard containers, in the hashed containers. So what is this about? It's about having a map or a hash from string to whatever. And you don't want to construct a QString or a stud string just to look up the key, right? You have a string view or you have a QString ref or even a char16 character array, and you want to use that to look up stuff in the container, and this presented how to do that using QStringView. It also contains some technical deep dives about how we manage those overloads, so that we actually can overload QString and QStringView without ambiguities. And also a detour into contracts, which unfortunately did not make it into C++20, so we have to wait until 23 for that. But that was showing how the use of QStringView in the API, instead of the more or less equivalent QChar array or QChar star and int, 2 arguments, can lead to functions having less preconditions, because whenever you pass in a pointer and a length, you have the precondition that they form a valid range. And QStringView has that too. So if you get a QStringView in, you already know that it's valid, because otherwise the undefined behavior, the precondition violation, would have happened outside your function. This has some consequences. that this talk also talks about. That's the URL, that's the QR code, so I saw you all raise your handy. So it's a prequel talk to this, and we're repeating some parts here, but not that much, because there has been not much progress since the last talk, but there has some progress that we will talk about. So this is straight from that talk, because I want to set the stage of how QStringView works. So we have here a small function, isValidIdentifier, which is implemented in terms of two other functions, which just take QChars. And the idea is to return true or false, depending on whether the string as passed is a valid C identifier. So it starts with a letter or an underscore, and once it's done that, it can also contain numbers, right? So we need to check the first character separately. We need to handle empty identifiers here. And an empty identifier is defined as non-valid. If the first character is not a valid first character, then it's invalid. And otherwise, we iterate over the rest. And if we find a non-valid follow-up character, then we return false. Otherwise, we return true. Simple as that. The problem is that we are taking QString in the API, like you know from Qt, everywhere QString is used. And that leads to the following. Here, if I'm converting from a local 8-bit to const-char to QString, I must allocate memory because I need to have a buffer into which to convert to. There's a different width of character types, so I need to have some conversion. But here, this also allocates, and this is just a constant. I mean, I don't need to convert. I can write a U in front, and it will be a white UTF-16 character. And we want to fix this. And in the first step, it's as simple as replacing the argument. So I've done nothing but replace the argument from QString to QStringView, right? And now that we pass here in the bottom, this also changed because we put a U on top. That's a C++11 car16T literal now, which has an implicit conversion to QStringView. So QStringView can accommodate both the standard string literals, given the correct size. On Windows, it can also do that with long string literals, as well as QStrings, with not much change to the caller, and with mostly no change to the implementation, right? But once you have a QStringView, you see we are basically dropping down immediately to using iterators, because these operations that we are performing there, which we'll now see in the next slide, or next slides, they're expensive for QString. Yeah. That's why we, in this kind of parsing functions, the first instinct is to drop down onto the bare metal, either using directly pointers or at least iterators, to get away from those expensive member functions. But in QStringView, these member functions are all totally cheap. So what we first did, we replaced iterator is empty with iterator equality with is empty, and we replaced the first dereferencing of the iterator with a call to front, which returns the first element. We still need to have the iterators around because the while loop still uses them, but we have now handled the first element without iterators. So in the first line, we now need to call begin +1, just to skip the first character, which was already handled. So in the next step, we can simplify this further and use range-based for. And we need to skip the first character, as we have always done, but calling string.mid would be totally expensive on QString because it would reallocate. Right? With QStringRef, it's not quite so expensive, but with QStringView, this is just one pointer increase and corresponding decrease of the size. So it's totally cheap, it's totally in line, and it's as efficient as the code that you wrote before, but much more readable because you use higher level API. Yeah? So this sets the stage for QStringView, and so let's look at what the present has in store for QStringView. One thing I forgot. What did I change? I made all the functions const expr, which I can because now I'm no longer allocating memory. And now this last line that I'm printing, that's a compile time constant. This valid identifier of a valid identifier returns true at compile time, and otherwise, if it's not a valid identifier, it would return false at compile time. Right? This is also not possible with QString. It might be possible in C++20. You can allocate memory in const expr functions, but we're not there yet, and it will be years before Qt can depend on that. So until then, we have to make do with QStringView. So now, present. So what has changed? Most of the const QString functions that we want on QStringView are now available. The biggest omissions were index off and last index off and stuff like that. QLatin1 string, as promised, has the same features as QStringView. So whatever you can do with the string view, you can do with the QLatin1 string. I heard Lars saying that QLatin1 string is no longer needed. I disagree whether it should not be included in Qt6 because we are teaching people to use the QLatin1 string overloads of functions all the time when they're available because they're faster right now. And if you don't want to totally break Qt5 applications going to Qt6, you will need to have this as a compatibility inside Qt6 too. So, the biggest change since 2 years ago is that multi-arg can now take any number or type of arguments as long as they're converted to any of those types. And I will show you what that means. So arg comes in two different flavors. The first one is the traditional arg where you have a number or a string or a character, and then you have some formatting options as additional arguments. I call those unary arg. And you have the argument which can replace many strings in one go. I call that multi-arg because that was the name of the private implementation function prior to what we have now. So we're now talking about multi-arg. That's the arg which can be called with any number of strings and replaces them all in one go. So it builds an internal representation of the format string and which replacements to make, then allocates memory once, makes all the replacements, and then returns to the string with just one memory allocation. I'm lying, but we'll come to that. So this is now, first of all, also available on QStringView and on QString, QLatin1 string. Yeah, so if you have a constant formatting string, you no longer need to construct a QString just to be able to call arg on it. You can just use QStringView or QLatin1 string, even if it's a Latin1 string. And it will just work. But all these still return QString because you need an owning container to return them. You cannot return a string view of something that you temporarily created in your function. That's not possible. You need an owner. So what with the unary args, they are currently intentionally unsupported because we are awaiting that new feature Q-formatted number, which will then tie in with the multi-arg. More on that later. So this here, those two lines still work and have been working for quite some time already. Oops. I don't know why it doesn't work here. Never write your own presentation software. Bad idea. Okay, so can't highlight. So imagine that I highlight the first and the second line. And of course, they are basically the same. The first time I'm constructing a QString from a const char star, or character array. And the second time I'm using this compile time QString version, but it also returns me a QString. So in both cases, I'm calling QString of arg. And I'm passing in Latin1 strings because that's what I have. There's no QASCII string anymore. So Latin1 string is the closest that I have. But the arg methods in Qt 5.13, they take QStrings. Up to 9 QStrings, but QStrings. So when I have this expression in Qt 5.13, I will allocate memory 3 times. Once for passing, or twice for passing the argument in line 2, and once more for constructing the result. And the first line, of course, allocates even 4 times memory, right? So, if you use QStringView or Latin1 string and arg, we at least get rid of the allocation on the left-hand side, on the format string. And even if you say, okay, we had that before with QStringLiteral, QStringLiteral has the problem that every instance is a new type, and the data that you store in a QStringLiteral is not shareable between instances of QStringLiteral. Whereas if you have a character array that the compiler understands, it's allowed to share copies of those and reduce the size of the executable for you. Also, if you just have Latin1 strings, you don't need 2-byte characters to store these things. We still have the allocation in the arguments because it still takes QString, and we are passing QLatin1 strings, but we'll fix that now. Because now arg not only is supported on QLatin1 string and QStringView, it also supports more argument types than just QString. It supports Latin1 string, QStringView, and QChar, and everything that is implicitly convertible to it. Yeah? How is that even possible? For example, std_u16 string is implicitly convertible to QStringView, so you can just use it in arg now. It will just work. So how does this work? Arg is now a template. Before it was an overloaded set of 9 functions, and now it's a template, so it can accept anything and internally tries to match it either to Latin1 string, StringView, or character. I can show you later when we have time how that is implemented. And you do not get a conversion to QString anymore because you're accepting all these things, and the only thing that you're converting to are those 3 on the top, and note the absence of QString. These are all more or less view types, except for QCharacter, which is cheap to copy, of course. So, taking the same thing here, again, that we had on the previous slide, now we have exactly 1 memory allocation as we want it to be. Because we're no longer converting the Latin1 strings to QString to pass them to arg, but we accept them as QStrings, as QLatin1 strings, and pass them through the ABI boundary into the multi-arg algorithm. And so the left-hand side of the dot no longer allocates, the right-hand side, the function arguments no longer allocate, and we are left with the 1 allocation that we want when the format string is taken and the arguments are taken with the format string to form the result. This means we can now also pass more stuff. So we can, for example, start passing character literals, char16 character literals, because they implicitly convert to QStringView. We can pass QLatin1 chars because they implicitly convert to QChar. And the idea here is that you should not need to construct a QString just to make a format string, and neither should you need to construct a QString just to pass arguments to arg. Yeah. And because we're now 4 times less memory allocations, rule of thumb, this thing 4 times faster. At first approximation, the number of memory allocations that you have is proportional to your runtime and these kind of things. The implementation uses qvar length array, so it does not allocate memory there. If it does not need to, if you don't pass more than 16 or so arguments. So, arg can now also take more than 9 parameters. If you ever needed that, I needed it once for the kmail welcome dialog, where there were so many parts that you needed to call args twice, and when you have to call arg twice, you always run into the problem that the first arg might have replaced with something that contains a placeholder, and then you're replacing on the wrong position. So this is nice. It falls basically out of that is now a variadic template. And on QString we fixed that too. So all those handwritten functions, they are still there for binary compatibility. But the main arg will now be the variadic template. It's a perfect forwarder, so it will match anything that you give it. So here's an example, up to 12 arguments, no memory allocation, or rather exactly 1, because everything is statically allocated. Woo, I'm almost out of time. Yeah, when you say, but I need this singular arg, yeah, wait a bit. We want to get rid of this incompatibility between string and non-string arguments. So this, what I show there, does not work. Yeah, it might not compile, or it might compile and the num bytes are some formatting option of the num files. But we want to make this happen, and this is why I envision this. So you get the locale, you get the string, and you get some formatted options, but instead of getting a QString back, which would again allocate, which is why nobody's doing this, you return a formatted number, and if you want to know more about formatted number, go look at the previous talk. And this piggybacks on the multi-arg work, so it's arg now is easily extendable to more than 1 type of argument. Future. So the plan is to complete the const QString API, including split for Qt 5.15. Q formatted number, Q parsed number, whenever. For Qt 6, I still intend to write a Q UTF-8 string owning and Q UTF-8 string view non-owning. And for Qt 7 or 8, I would really like us to get there that Q byte array is an array of bytes and not a sum string. The same thing that Python did also when they went from 2 to 3. They realized that there's a difference between byte array, and a string. So what's intentionally unsupported? Mutating functions, they are out of scope for a view. Unary arg, talked about that. Number and toInt and toDouble, they are going to use the new formatted number and passed result, passed number. So what's mainly missing? QRegular expression support. There's the guy. Split. There's a working implementation, but it's not cleaned up yet, and Thiago has some stuff against it that needs to be addressed first. And of course, number string to number conversion that uses the new API. So what's the deal with split? Why did it take so long? What's the problem here? Remember, we are using QStringView to reduce number of allocations. That's the problem. QVector is a dynamic container, so it needs to allocate memory because it does not know how much elements you will feed it. So the solution here is QString Tokenizer. It's basic, it's a generator, concept generator. It's a C++20 coroutine, but implemented in C++11. And this is how you would use it. So you can just iterate over a QString iterator. This unfortunately uses C++17, so we'll talk about that. With C++20, you could write this function which returns a lambda, that you can already do in C++14. And then you could use ranges count if, which is new in C++20, to return the whole thing from a standard algorithm. So what's the deal with the template arguments? Because QString Tokenizer is surely a template class, but you don't see it because we've been relying on C++17 constructor template argument deduction or class template argument deduction. And Lars said that we can assume C++17 for Qt6. I'm still not so convinced, so split will not go away because it's needed to deduce the QString Tokenizer template arguments for us. So you can also write the same with s.split. So object lifetime is always a problem. You have some function that returns a string, and if you use a string builder expression and store it in an auto variable, and you execute the semicolon at the end, now you are referencing deleted content because the string builder expression does not keep the R value QString alive. This is not a problem with QString Tokenizer. It does the correct thing. So if you pass it an R value, it will store it inside. If you pass it an L value, it will store a reference. That should be added to QString Builder too in Qt6. So number conversion API, this is more or less straight from the old talk, so I'm going through it a bit quickly, also because I just have 4 minutes left. So this is what we have currently, and that is bad because allocation. For just formatting numbers, we don't want to allocate. So we're returning a formatted number, which is basically a description of the arguments plus an internal buffer that can hold the result. So we don't allocate. ToInt, the problem here is the out parameter. So using it is totally awkward. And when you want to return something, use the return type. That's my hint. So we could use std_expected, but std_expected is more or less dead because Herb Sutter has one of his glorious new proposals again. There's QResult, which I don't know where the state is of, but that should be equally dead for the same reason, but probably isn't. That will be the next tie-in. So what we should do is we should just return our own type, and then it can use an std_expected or a QResult internally, and then we insulate our users from whatever the future brings. And the idea is that it's some kind of optional, so we return from ToInt some object that you can test for with the bool conversion, and dereferencing operator gives you the result. Otherwise, you need to call R_error to handle it. So this is Herb Sutter's idea how to do this. Basically, he proposes to have a new throws keyword, which can throw only one kind of exception, std_error, and which piggybacks on the return type. If you want to know more about this, then I suggest you listen to his talk from CPPCon last month. And then it becomes as easy as this, and we have exceptions, but we don't have dynamic exceptions, so we don't have the overhead, blah, blah, blah. And the last part that I want to address in 2 minutes is what is a qbyte array? Short answer, we don't know, because it might be binary data or UTF-8 string. So we don't know what this function accepts. And QStringView, QUTF-8 string, QA-UTF-8 string view might be a partial solution for this. QStringView, QUTF-8 string view is like QLatin1 string, but for car8Ts. So we would really like to have car8T from C++20 available when we do this, because it makes things so much easier. UTF-8 string would be the owning version. And whether we need QLatin1 string view is up in the air. Lars says no. I say at least for Qt6 for compatibility, we probably need it. So and the conversions from UTF-8 string to QString would be implicit because they're non-lossy. Likewise, if you have a car8 array, then you would implicitly convert to QUTF-8 string, but not from QByte array and not from constCar*. And I want to finish with this little overview. There we go. So we already have for this situation for UTF-16, we have QString as an owning container. We have QStringView as an observer, as a view. We want UTF-8 over car8t, if we can afford car8t support to be required, which is C++20 feature. We would have a string view over this. And then we would have byte array as an vector of byte. And then the question is, will we have a QByte array view? And I don't think that makes much sense because we have standard containers, string view or span of byte array of byte, which can do the same thing. And car, an unsigned car and Latin1 string become unsupported. You will need to use U or U8 to pass strings to the interface. And with this, I finish on time. Thank you.